Hello everyone, welcome back to this new video of this Solidity learning series. This is Arvind Kalra, and in this video we are going to learn about some new concepts in Solidity. We'll continue working towards building the polling DApp that we started in the previous video. The idea of the polling DApp is anybody can go in and deploy a new smart contract which literally would create a new poll, and then he or she can share that contract with others who can go in and cast their votes. And then there should be a functionality to calculate how many votes were placed for which poll item. So let's get started. Let's go back to remix. So see, we have the contract that we guys wrote in the previous video, the polling dApp. We need to make some changes in here to make it ready for use. So let me write down as comments what all changes need to be made and what we will do in this video. First thing would be, right now you can see the question and options, both of them are written as code. So basically they are embedded in the code, which makes the contract not modular. But we need the contract to be modular. Anybody can deploy a new contract to start their poll. They don't need to have the knowledge of writing Solidity. So we can't keep this question and everything in the code itself. So the first step is to make the contract modular. So to do that, we'll use something called a constructor. We'll go into the detail when we start writing the code. The next step would be we'll be creating a function to cast a vote, and this function will do pretty much what its name already suggests. It will be used by any user to go in and cast their vote for the poll. The third part that we will cover in this video would be making sure that a user can only vote once. So we don't want users to go in and cast multiple votes and basically pollute the data. So the idea would be allow a user to cast the vote only once. But in Ethereum, we don't identify user by their name or anything. We use their Ethereum address to identify a user. So I'll write this thing: allow an Ethereum address to cast a vote only once. And while writing this function, we will use something called message.sender. I'll cover in more detail what we will do with message.sender when we write the actual function. First thing first, let's get started with writing the constructor to make this contract modular. So before writing the constructor, let's understand what exactly is a constructor. So in the first video, I conveyed this thing that Solidity programming language is an object-oriented programming language. And for those who are from the object-oriented programming language would know what is a constructor. But for those who don't know, this is what is a constructor. So constructor is a function which is called by default whenever a contract is deployed. So let's say I'm deploying a contract X, and while deploying a contract, I need to write some code which runs as soon as the contract is deployed. So constructor is the function that I'm going to use to write that code. So let us write that. So to write a constructor, the constructor starts with this keyword called constructor. And just like any other function, we can pass arguments to this constructor. So in this constructor, we want that a user should be able to pass the question, also the options to start a poll. So the first argument will be a string, and when it comes string, we write memory as well, string memory, and then I'll write underscore question. So the user will pass the question in the constructor. Then the second argument will be an array. Array is basically a group of strings kept together. So array can be of type string or an integer. So right now we'll be using an array of type string. So for that we'll write string square brackets because we want to write an array. Then we'll write memory, and then I'll write options. And yes, and then we open the curly braces. So everything that we write inside a function stays inside these curly braces. So we got the arguments. Now the next step is to use these arguments to set these properties, question and options. So the simple way to do it is write question is equal to underscore question, semicolon, and then options is equal to underscore options. As simple as that. So this constructor would do the job, but also we don't want the variables to be defined here, so we'll leave them as undefined in the beginning, and when the constructor is called, it will automatically assign the values to these. So let's see if it works. Let me save it. Let me go to the compiler. It compiled. Let's go to deploy and run transactions and see. Earlier we just saw the deploy button. Now we are seeing these two values in the deploy button itself. So right now, the earlier the constructor was not expecting any argument. So as I told you, constructor is needed whenever a contract is deployed. Earlier the code did not have a constructor, so Solidity itself provided it a constructor with no arguments. But now we are writing the constructor explicitly, so we can define our own arguments, and those are required over here. So let us deploy the contract. I'll use the same question, which is this thing: what is the best blockchain in the world? Yeah, you can see it. Then also we'll need all the options. We'll paste the options and hit transact. So when we hit transact, it will deploy the contract. We are using the JavaScript VM London. So yeah, it deployed the contract. So here we can go in and interact with the contract. Now here we have the functions, which is get options that we wrote over here. Also we made options and question public, so we have those as well. If you click on question, it will return you the question that we passed in the constructor. And also if you go to options, you can pass the index of the option that you want to retrieve. So it starts with 0. If I pass 0, it should return Ethereum because that is the first option. Then I can pass 1 to fetch the second option. But if we don't like to call blockchain multiple times to fetch the options, we can use this function get options that we wrote earlier. If we click on it, it will return us all the options, comma separated values. Cool. We have reached the completion of first step that we wrote. I'll write completed in front of it and remove it. Let's get started with the second part of this video, which is writing a function to cast a vote. So let's first understand what is the expectation of the function. So the cast a vote function will take an argument, and the argument would be an integer. So let me write that here so that we don't forget it. Argument, and it will be integer. Correct. So this integer will basically define the index of the option that the user selected. So if the user selected the first option, it will pass 0. If he selected the second option, they will pass 1, and so on. Then we'll store the user's selection somewhere in the contract. So we need that storage in the contract. So for that, we'll create a mapping. So the mapping will basically store uint to uint, where the first uint will basically define the option index, and second uint will point to the number of votes casted to that index. Sounds good. So basically the idea of using this mapping would be to store the number of votes casted on each option. I'll make these comments so that we don't get an error on the compiler. I guess that's pretty much it that we expect from the cast a vote function. First, I'll create the mapping that will store the count of votes for each option that I defined over here. So going ahead, I'll create a mapping, and as told earlier, the mapping will be uint to uint mapping. And let me call it vote count. So this mapping will store the number of votes casted for each option. I'm also going to make this mapping public so that I don't need to write a getter function which will return the count of votes for each option. So public will automatically return give us that function. So we'll create this mapping, and let's go to writing the cast vote function. The function starts with the function keyword, then we write the name of the function, which is cast vote. Then we pass the arguments. Over here the argument is uint type, and it will take option index. So option index is the index of the option that the user has selected. Then we want this function to be public so that anybody can use this function to cast a vote, and works. Cool. So we have the function definition. Let's write down what the function will actually do. So the function will do this. First, it will uh, fetch the existing number of votes for the past option. Then it will increase the number of votes for the past option, and then it will update the vote count storage that we declared above. So the first variable would be uint, because I don't know why I have this habit of writing unit instead of uint. So it is uint, and let's call it existing number of votes. And then we'll fetch the number of votes casted for this option index. So for that, we'll access the vote count and get the number of votes that are present. So for that, we'll write vote count, and then we have these square brackets, and then pass the option index. So what it will do is it will query the vote count data store that we have, which is this mapping, and it will fetch the value for option index, which would be the number of votes casted for this option. Then we'll calculate the new number of votes, or I'll call it updated number of votes is equal to existing number of votes plus 1, because the user has voted, so we want to update the value. Now we have the updated value in this variable, updated number of votes. Now we need to update this mapping, which is vote count. So for that, I'll write this vote count, and to access the option index, we'll again need to use square brackets, and we'll write is equal to. So see, so this basically assigned the updated number of votes to this option index, which is expected from the cast vote function. But if a user does not get output, they will feel that something went wrong. So I'll return a string, call it congrats, your vote is counted. Now, since we returned this string, return this output to the user, we need to write this returns in the function definition as well. So I'll write returns and say string memory, because this function is now going to return a string. So that's why I wrote returns string memory. Let's see, and I hope it gets compiled in the first. Yeah, it compiled. Let's go back. Let me delete this function because I don't think we need it again. Cool. So I'll again deploy the contract. Here is the question. Here are our options. Transact. Cool. So the contract is deployed. See, we have this new function which is cast vote. First, let us get all the options. Now we know we have these many options. Let me cast my vote. First, I'll cast my vote for Ethereum because I love Ethereum. So let's go back to vote count and see the number of votes for Ethereum. If I pass 0, because Ethereum is the first option, that's why I'm passing 0. If I wanted to fetch the number of votes for Bitcoin, then I'll have to pass 1 because that is the second argument. I'll call and see I got 1. If I pass 1, ideally nobody has ever voted for Bitcoin, so that's why it should return us 0. Let's see. Cool, it returns 0. I'll go for 2. That also returns 0. Now, since we haven't written the logic to block a user from casting more than one votes, I can go in and cast my vote for Bitcoin and Solana as well so that they don't feel bad. I'll cast another vote for Bitcoin. Now let's see the vote count. If I do one is Ethereum. There is just one vote for Ethereum. If I do, sorry, there is just one vote for Bitcoin because I passed one. Now I write 0. Fetch, there is just one vote for Ethereum. If I do Solana, for that I need to write 2 because it is the third argument. I do call and it returns 0. And once more, I'll basically cast a vote for Ethereum so that we can see the numbers are increasing. I'll cast vote for Ethereum and check the number of votes for Ethereum. See, it updated to 2, and I can fetch the question and do everything. So that's it. This way we wrote the cast vote function. Sounds good? So we have that function completed. Let's remove it from here. Now we just have a single part left, which is allowing an Ethereum address to cast a vote only once, or we can say that we want to restrict an Ethereum address from casting more than one vote. Cool. So for that, we need some data storage where we'll store whether a user or whether an Ethereum address has already casted a vote or not. So for that, I am going to create another mapping. I'll call it, let's do write down mapping, and this mapping is going to be from an address to maybe uint. So I'll tell you what I'm thinking to do. I'll write address to uint and I'll call it public. I don't think we need to make it public. We can skip that. So I'll write casted votes. So basically this mapping will store which address has casted how many votes, right? So we'll keep on updating. So address is basically stores the Ethereum address of a user, of a contract, or anything. In this data type we can store address Ethereum addresses. So in this mapping will store which address has casted how many votes. I'm writing uint for that, the number of votes for the address, the number of votes which an address has already casted. For now I'll make it public so that we can see if it is working perfectly. Sounds good. And over here, earlier we were just updating the number of votes casted for an option. Now we'll update the number of votes casted for an address as well. So I'll write uint and existing votes by caller. Caller is the one who is calling this function, and let's say casted votes. And yeah, now since earlier the user had passed this option index in argument, so we could just pass option index over here. Now also we can take an address as an argument of the caller and then use this caller address here to do just what we did earlier. But that is not a very good idea, because assume that I am the user, I use one Ethereum address to cast one vote, then I use another Ethereum address and cast another vote, because I'm just passing those Ethereum addresses in the argument. So I can pass any number of Ethereum addresses whether or not I own them. So that won't block me from casting more than one vote. So it is not a very good idea to take the caller in the address. What we need to do is we need to see who is the one who casted the vote without passing it in the argument. So if I have a private key, when I sign a transaction and send it to the contract, there would be an address attached to my private key. So there should be a way in Solidity to fetch the address for that private key which was used to sign that transaction. So next time when I send the same transaction before the same function, the same address will be received by the contract, so they would be able to block me. So for that we use something called message.sender. We already have this keyword in the contract. We can use this to see who was the sender of this message, who was the sender of this transaction of calling this cast vote function. I'll declare this here, address I'll say that caller is equal to message.sender. So basically caller will store the address of the sender. Now we'll go back to the previous part which we were working on. Existing votes by caller, casted vote, and we know the existing votes which are casted by the caller. Now we'll do uint, and I'll do same like the number of votes. I'll say updated votes by caller, and I'll say existing number of votes plus, not existing number of votes, existing votes by caller, and I'll do +1, and I need to set this value in the casted votes mapping. So I'll do this casted votes, let's say caller is equal to updated number of votes. Cool. So we have this function ready. So ideally when I use this function again, if I cast a vote multiple times, it should allow me to cast the vote multiple times because I don't have any check over here. But if I use this casted vote mapping, if I use this, I would be able to fetch the number of votes that I have already casted. So if I cast, let's say 5 votes, I would see this value, the y value using this mapping. Let's see if that works. We got some warning. What it is saying? Unused local variable. I think I used the wrong thing. Yeah, I used the other updated number. Cool. We save it. Let's go back here. Let me close this, delete this contract which was deployed earlier. I'll again deploy a new contract, and for that we need a cushion and the options. Let me copy it. Cushion, and then we need the options. The contract is deployed. Now you can see we have the mapping of public mapping of casted votes as well. I'll again see the options that we have. Ethereum. Now I'll go in and cast a vote for Ethereum first. So I'll pass for 0. Then I'll cast a vote for Bitcoin, and again cast a vote for Ethereum, and I'll cast a vote for Solana as well so that it does not feel bad. So what is the number of votes that I've casted? 2 for Ethereum, 1 for Bitcoin, and 1 for Solana. So 4 is the total number of votes that I have casted. Now this casted vote mapping should return the value 4. See, it is expecting address. So in this address, we know that we need to pass the Ethereum address which is being used to cast the vote. We can get that Ethereum address from here. I go here, I copy the address, I'll again go here, paste the address and call. See, it says that I have casted 4 votes, and we can again go and then see the vote count. If I do 0, since I casted 2 votes for Ethereum, it should return 2. Since I casted 1 vote for Bitcoin, it should return 1, and I have not casted any vote for none of the above, should return 0. Sounds good. We have the contract working well till now. Let's come back to the function. So our expectation was to restrict a user from casting more than 1 vote. But what we are doing right now, we are counting the number of votes casted by a user. We are not restricting the user. For that, we'll use something called require. So require is a function which is provided to us from Solidity. We did not have to write down that function. We have not written require anywhere, but that is a function provided to us by Solidity. So the idea of using require is require basically takes a condition as the first argument, and it makes sure that the condition is met. If the condition is not met, it will throw an error. So let me show you how it works. I'll write this condition over here. I'll say require existing votes by caller should be equal to 0, and I'll write error, you can only cast once. Cool. I guess you must have already understood what require does, but let me reiterate. Require basically makes sure that the first argument, which is this condition should be met, only then it will allow the code to go further. If this condition is not met, it will return this string as an error and stop the transaction then and there. So what is the condition that we wrote here? We want the existing votes casted by the caller should be 0. So if the caller has already casted a vote, this value would be 1, and we don't want the user to go, the code to go any further. So we want to throw an error over here. That's it. So let's save it. The contract compiled successfully. Let's go back. Let me delete this earlier deployed contract and redeploy the contract. We again need this question. Let me copy it here. We need the options. Let me copy them also and transact. Cool. So the contract is deployed. Now we have just the same number of functions, but something is changed. Let's see what has changed. First, let me get the options. Let me see the number of votes that are casted. Ideally, for each of them, it should be 0. Sorry, it is expecting an address. For that, we need to use vote count. Casted vote basically fetches the number of votes casted by an address. Let me go to vote count, call 0, and for my address, if I go to casted votes and call, it returns 0. Now let me cast a vote. This time I'll cast a vote for Bitcoin. I'll write 1 because that is the second option. I'll use 1. I'll transact and the vote is casted. Also, we returned this message. We did not see this message over here. That is because this function is making some change in the contract. That's why it is a write transaction, and the write transactions won't show their message over here. If you want to look at the message, you need to go here and see. You can find out, congrats, your vote is counted. Cool. Now the here comes the main test of the final contract. I should not be allowed to cast more than one vote. So if I want to cast another vote for Ethereum, let's say, because now I love Ethereum, if I click transact, it should error out. Let's see if it does. And see, it did. It basically threw an error, and the error also says error, you can only cast once. So see, the require worked. Now I can only cast a vote once. If I want to cast more than one vote, I need to change my Ethereum address. To change the Ethereum address, I can go here and click the second option. Now again, if I try to cast a vote for Ethereum, it should allow me because the address has changed. Now I'm using a different Ethereum account, and yeah, the vote is counted. We can see the number of votes for each option. For 0th option, it is 1 because the new Ethereum address has casted a vote for it. And if I check the number of votes for Bitcoin, it should also return 1 because it has also got 1 vote. Now, if I try to cast a vote again for this through this user and I click transact, it returns an error. So this is how we write require and constructor and message.sender. I think that's pretty much what we thought about completing in this contract. Yeah, that's it. Cool. Let me reiterate on what we did or learn in this video. First thing was we made this contract modular. For that, we wrote this constructor. So the idea is of constructor it is this is the function which is called as soon as the contract is deployed. So this is the first function which is called when the contract is deployed. It can also take arguments. Here we took 2 arguments, which is question and options, and we set these values into these. So now anybody who does not have any idea about Solidity, he can also use this contract. Just pass the questionnaires and options in the arguments and deploy a new contract. So we made the contract modular. Next, we created a function which is used to cast vote. The cast vote function uses message.sender to fetch the caller or the Ethereum address that is calling this function. We fetched the existing number of votes for this option. Then we updated the number of votes for this option. Also, we fetched the number of votes casted by the caller. by using this. Then we saw that whether the user has already casted a vote or not. So for that we use require, which made sure that the existing number of votes casted by the caller should be 0. If he has already casted a vote, this value would be 1, and it will throw this error and won't allow the code to go any further. Next is we updated the number of votes casted by the caller, and all these values were in local, they were not persisted. So to persist them, we updated the mapping that we declared above, which is vote count and casted votes. And to do that, we wrote this and we returned this message: congrats, your vote is counted. Cool. That's pretty much it for this video. In upcoming videos, we'll learn more about different new things of Solidity, and we'll go ahead and improve this contract. This is very basic contract for now. We'll add more functionality in further videos. Feel free to discuss anything about this contract in Discord. I'm happy to answer your questions. Also, I got some comments that the text size of Remix was not big enough. I hope this video solves that issue as well. Sounds good. Cool, guys. Bye bye.